Hello, this is Kumar Singh from Design Analytics LLC and welcome to another episode of Thursday Throwbacks. Well, the throwback or the historical timeline that we are going to discuss in today's episode is related to logistics regression. Yes, the very popular machine learning tool or model that's leveraged across functions in marketing for churn. You can apply it in merchandising, in retail, actually even in inventory management, which I haven't seen much, but you can, right? So let's jump into the history of it. Well, we know what is logistics regression is a foundational model in statistical learning and machine learning, and it has its root in 19th century probability theory actually, and it evolved through biostatistics and social sciences. So we will briefly recap the history and then get into some of the key timelines, right? So while there is kind of a timeline, a succession of work or a plethora of work that led to logistics regression, right? So while it has roots in earlier work, Joseph Berkson is credited with introducing and popularizing it as a general statistical model. So he specifically coined the term logit in his 1944 paper, right? And that laid the foundation for the widespread use of logistics regression. Prior to his work, the logistics function had been used in other contexts, but he applied it to statistical modeling, I think in the field of bioassays. Right? So basically, a little bit of more detailed breakdown would be that the logistics function itself, as you see here, right, it was introduced much earlier, but by Pierre-François Verhulst, if I say the name correctly, in actually 1838, right? And it was used to model population growth, but it wasn't initially used in a statistical modeling context, right? So Berkson, while working on bioassay, proposed using the logistics function instead of the normal probability function, right? And he introduced the term logit to represent the logarithm of the odds, right, which is used in the formula, which is a key component of logistics regression. David Cox is another another statistician. He was a British statistician who built on earlier work, right, to formally define logistics regression as a method for modeling a binary dependent variable. So these are the two key people, but generally Berkson's work is considered the starting point for logistics regression as a widely used statistical method. He continued to develop and popularize the model in his subsequent publications. So with that, I'm kind of touching upon the key players in the history of logistics regression modeling. Let's now look at the timeline. 1838, as mentioned, Pierre-François, a Belgian mathematician who first proposed the logistics function, right? And he was modeling population growth. Again, the function is this. The S-shaped curve, right, for this function modeled how population grows rapidly and then levels off. Right? In 1908, William Seeley Gossett, under the pseudonym Student, student distribution, I think, laid groundwork in applied statistics, though not directly in logistics regression. In 1944, Chester Edner Bliss introduced the term probit analysis, using the cumulative normal function to model dose response in biology. And then in 1944 itself, Joseph Berkson, while working on bioassay, proposed using the logistics function instead of the normal probability function, right? And he leveraged the term, right, logit, or he introduced the term logit to represent the logarithm of the odds, as we mentioned earlier. Then, as mentioned, in 58, David Cox, British statistician, built on earlier work to formally define logistics regression as a method for modeling a binary dependent variable, right? As you see here, this log odds transformation makes it a generalized linear model, GLM, right, using the logit link function. it has adopted widely in many different fields and functions, right? Initial work was in medicine and epidemiology, I think, then social sciences, right, 1970s to 80s. Now, under the bucket of machine learning, it has seen a lot of use cases across functions, right? So, to summarize, logistics regression, a baseline classifier in binary classification, interpretable and computationally very efficient, has a rich historical timeline as well, and it's fascinating to learn about history of these amazing tools and technologies that we use today. And it was interesting to learn that how logistics regression evolved, because we know that logistics regression is kind of a precursor to more complex models like neural networks and ensemble methods. Thanks for watching. I'll see you again next week.